Katie Technologies.
Hello and welcome back to Projects in Java. Today we are starting our game project. Today we'll be building a block breaker game. So let me go ahead and demo that for you and talk about the objects that we're going to be using. So here we have the finished project. We can press enter to start the game. And you have some power-ups to launch extra balls. And you have the blocks on top that are being destroyed when they get touched by the ball. And the paddle moves left and right using the arrow keys. And it's a pretty simple game, but it is pretty fun, and it has a lot of moving parts, a lot of different code that we need to implement. We have AWT. We're going to be using a lot of classes from this toolkit. It's called the Abstract Window Toolkit, and we'll take a look at those imports right now in a bit. Okay, and so if you read on this page, it says that it gives us objects to windowing, graphics, and user interface widgets. So that's things like rectangles, you can display images. So each of those blocks was an image, but it was also a rectangle, and we'll talk more about that. The first thing we're going to create is our window. It's called a JFrame. So let's create our project, and this is just a regular Java project this time. And we'll call this block breaker. And we'll create a main class while we'll start the game. So here the first thing that we're going to need is our main function. And after we have this, we will create, and so we'll create our JFrame. We'll call this frame equals a new JFrame. And we can pass this a string argument. And this string argument is going to be the name of the window. Okay, do our import. Let's set frame to visible. Equals true. We'll also set the size. And the next thing we want to do is set the default close operation. And the reason why I want to do this is because the Java executable will still be running even when we close the window. And if you run it a few times, you'll end up with a lot of processes from Java. And this is how you set it. Okay, and we can test this. And here's our block breaker window. And so in our JFrame, we can add JPanels. So we'll need to create that panel. And we're going to use a new class that we're going to make right now. We're going to call that block breaker panel. Panel equals new block breaker panel. Okay, we'll add that to the frame. Now we need to create that class. Okay, and our block breaker panel is going to extend JPanel. Do our import there also. The first thing that we're going to add here is some array lists. We'll start off with one first. And so the way the array list works is that you can create an array list of certain type of objects. You can do integers, strings, anything like that. You can create an array list of objects. And so we are going to create a new class called block, and we'll create an array list of blocks. So we'll call this blocks. Okay. And we'll create the default constructor. And now we need to create the block class. In the block class, we're going to extend rectangle. There's a lot of useful functions in rectangle. We have an intersect function that we'll be using later. We have width, height, the position. So by extending, we automatically inherit all of those very helpful functions. And so here we'll have a constructor that takes 5 arguments. We have an integer. We're going to have 4 integers and a string argument. Do our import of rectangle, and we'll set the values of the rectangle, our x and y, then our width and height. We'll also add an image in here. Do our import of that. So we're going to call our function from our toolkit. To get the image based on the string that we're passing in. And the last thing we're going to do from now is create a draw function. And so this is going to draw our block onto the screen. It's going to use the image. So we're going to call from the graphic, g.drawImage, and we'll have the picture, the x and y of our rectangle, with the width and height of our rectangle, and the component that we created. Do our imports. Okay. And so now we're going to add to the array list. We'll do our import of array list also. And to do that, we'll create a for loop. And we'll create 8 blocks. And we'll add to blocks. New block. Put in our parameters here. And I have an image that I need to put in. We'll create blue blocks first. Okay, let's copy our images to the folder. Okay. So now we have our blocks set up. Now we need to draw them here in the panel. So we have a function for that, public void paint component. And that uses a graphic. Do our import of graphic. And so here we're going to use a for loop based off of the array list. The for loop always iterates over all the objects in the array list. So for every block, call this B, in blocks, we are going to call draw from B. I'm going to pass that our graphic and this as the arguments. And there are blocks at the top. And we'll correct the size on that. That's actually because in the finished project, I have the resizable set to false. So in our main class, we'll set the frame resizable to false. And that should, yep. So that gives us the correct width and height for our blocks. We can create some more in different colors. And so we're just going to take the same for loop. We are going to move them down 25 pixels each time. So here 25, here 50, and here 75. And we'll change the colors, give some red blocks, some green blocks, and some yellow blocks. And there we go. So now we need to create the interaction with the ball. We need to create the ball and create the paddle. So and let's create a class and we'll call it animate. And this class is going to implement runnable. And so we have to have the function run. And we'll have a constructor that takes a block breaker panel. And we'll have a block breaker in here. And set that to the parameter that we have. Okay, and so while true, so that means this will run on a continuous loop. We'll have the block breaker panel update. And we'll create a new function for that. Okay, and then we want to sleep this thread for 10 milliseconds. And the reason why we want to do that is so that the animation isn't running too fast. Okay, and we'll create the update function in the block breaker panel. And then we need to surround the thread sleep with a try and catch. And so now we're ready to create some updates. The first thing we're going to do is just repaint. And so this will update the graphics on the screen. And we want to add a line here. And this is going to be super.paint component. And we're going to pass that G. And what this is going to do is erase the screen and then reprint whatever we call. Okay. We also need to add an implement here. And we're going to implement key listener. And if we hover over key listener, we do the import. And if we hover over the class, we need to add the unimplemented methods, and it'll add these three methods. And we're going to add to the key press method. Okay, and so here we're going to add if the key code is equal to key event dot vk score left. And then we'll do it if it equals right. So here we're going to want to move the paddle. Okay, and so then we need to create a paddle, and that's going to be a block. And so paddle is equal to new block. And we'll put that in the middle of the screen with a width of 150 and a height of 25. And we're going to use our paddle image. And we also need to draw this, so we'll put it in the paint component method. We paddle.draw and the same arguments, and that'll draw it. And so now here we can actually just set the x. So left will subtract from x, so minus equals 15. And here we'll add 2x, so plus equals 15. And then we also want to start the game. So if key code is equal to key event dot vk underscore enter, then we'll start the thread. And so the first thing we need to do is create a thread. Just name this thread. And our animate class. And so we'll set animate equals to new animate. And we'll pass it this. We'll set the thread is equal to new thread with animate. And we'll start the thread. Thread.start. Okay. And we also need to add the listener. So add key listener to this. And set focusable to true. Without these two lines, it won't actually read the keys. And before I launch it, I'll fix one thing here. This should be right. Launch it. And so it's not moving with the left and right now. If I hit enter, it should start. And there it goes. And so right now it's moving past the screen. We want to fix that. We'll set this here. So here we'll add an and paddle.x is greater than 0 and paddle.x is less than get width minus paddle.width. And that should keep us in the window. Enter to start. And we're going to create another array list. And this is going to be for the ball. And we're going to use the block class again. And so here we'll add the first ball to the array list. And we're using array list so that we can add some more later. And so we're going to add the first ball to the array list. So ball.add new block. And so this one is going to be centered in the middle, right on top of the paddle. And the width and height will be 25. And we'll use this image, ball.png. And so we'll use the same for loop. This time we'll use the other array list. Gonna run it, and so the ball is on top of the paddle. And now we need to create the animation for the ball. And so we'll go to the block class and add an integer for the movement. Actually, two of them for the X and Y. We'll set these to some defaults. So our X is going to be 3 and our Y is going to be -3. And so in our update thread, we'll create a for loop for each block BA in ball. And so we'll update the X coordinate. So plus equals BA dot DX. And we'll update the Y coordinate in the same way. All right, so the ball just launched and left the screen. So we need to set some restrictions. So if BA.x is greater than the width, so get width minus the size, and we'll create an integer for the size, which is the size of the ball. So that'll be 25. And BA.dx is greater than 0. Or BA.x is less than 0. And so what we're going to do here is we are going to change the x. So we'll multiply it by -1. So BA.dx times equals -1, and we'll do similar thing for the y direction. So we'll get the y coordinate. Y is less than 0. Or the ball intersects. So this is the function I was talking about. So if the ball intersects the paddle, we are going to flip the y direction. Same way, multiply by -1. And so let's test that. Okay, and so we have the ball moving around, but not destroying any blocks. Okay, and now that we have that set up, we'll make the ball destroy the blocks. Okay, and first thing we'll do is we'll create a Boolean variable in the block class, and we'll name this destroyed, and the default is going to be set to false. And in our update function, we are going to check to see if the ball intersects. And so we need to check all the blocks in blocks. So for each of the blocks, we are going to check if the ball intersects with the block. And also we need to check if the block is not destroyed. So if the block is not destroyed and it intersects with the ball, we're going to destroy it. So b.destroyed is equal to true. And we're going to flip the direction of the ball. Then in here, we need to make sure that it doesn't get printed. So if destroyed, if not destroyed, we draw the image. Okay, let's test that. Looks like it's just going through the block, so let's see. Make sure. This one update here, we're supposed to set this to -1. Let me test that. And it's destroying and bouncing off the blocks. And so the first thing we're going to do is add some left and right rectangles to the blocks. And the reason why we're doing this is because right now, when we hit the block, we're switching the Y direction. But if it's hitting on the left or right, it shouldn't change the up or down direction, it should change the left and right direction. So let's add some rectangles. So we're going to add rectangle left and right. And so left is equal to new rectangle. And we're going to base this off the input. So this is going to be a -1, then b, and 1 for the width and the height of the rectangle. And we'll do the same thing for the right, except we're going to do a plus w plus 1 and 1 for the width and same height as our block. And so now we need to go back to the update function and change our logic here so it recognizes the left and right rectangles on the block. So if b dot left intersects with the ball, or b.right intersects and b is not destroyed, we are going to multiply the movement by -1. Okay, and we also need to set b to destroyed. And so we'll add else here and some parentheses around the left and right intersects. And go ahead and test that. And so now you can see that it's bouncing off the side of the blocks differently than it would if it were bouncing off the bottom or the top. And so the next thing we'll add is an array list for some power-ups. And these power-ups can be anything you want. We're going to add an extra ball into the ball array list. So we're going to create a new array list with the block. This one's going to be named power-up. And so what we want to do is just add these to the regular blocks. And we can do that randomly. And so here, after we've created our blocks, we'll create a new random. So this is our random generator. Make sure we do our import. And so we'll do blocks.get random. We're going to get the next integer. And since we have 32 blocks, we'll put in 32 here. And we'll add a boolean right now. But we'll set powerup equal to true. And so we need to add this boolean powerup to the block. And we'll set that initially to false. And so the way this is going to work is that we'll choose a random number, and for that random number, we'll set the power up for that block to be true. And we'll set a few of these so that we can see them drop. And here in the update method, before the first for loop, we'll add another one. So this is going to be for each block, P and power up. And so what we're going to do is we're going to drop it. So we're going to increase the y. So p dot y plus equal 1. And so this will drop it each time. Each time the update function runs, it'll drop. And so here when we destroy the block, if the power up is true, then we'll add a power up to that array list. So if b.powerup do powerup dot add new block, and we'll set the coordinates to b dot x, b dot y, and we'll have the width and the height, and we have an extra .png image for that. Okay, and we need to add that to the else if, and we need to make sure to paint it also. So we'll copy this for loop again, and we'll change this to P and to power up, and P.draw. And so let's go ahead and test this. And there we go. So right now, if it touches the paddle, it won't actually create anything. It won't do anything. So we need to add that. And so we can add that here. So if P intersects the paddle, we are going to destroy P. So P dot destroyed is equal to true. And we can add another ball. So ball dot add new block. And we'll create this based off the paddle position. So paddle dot dx, and we'll take half of the paddle. So our paddle width is 150. So we'll do 75. And we'll use the same y coordinate from our first ball. And the same size. And we'll use the ball image. Okay, we also want to add here if it's not destroyed. So if P is not destroyed, otherwise we'll get a lot of ads. Okay, and let's test that. Let's see if I can play well enough to make this happen. Okay, there we go. And there's another ball and some more. And that's the complete project. There's still a lot you can do with this game. I hope you had fun creating this project and hope to see you in other projects.